Good morning, ladies and gentlemen. Thank you for the introduction. We're here this morning to present on 33 Grosvenor Place. We was fortunate enough to win the World Demolition Award for the urban demolition over 10 million at last year's event. So Brian and I will now run through the presentation. Project summary. Erith were appointed as principal contractor for the works. Our client was a private health clinic, which is the Cleveland Clinic, and it was their first venture outside of the USA to build a private clinic, and they chose London and 33 Grosvenor Place as that position. Temporary works were designed in-house by Swanton Consulting, and the project duration was 66 weeks. Project value at tender stage was 21 million, and the main items of work that were undertaken by us on site were soft strip, asbestos removal, top-down demolition of the 7-storey structure, facade retention to all 4 elevations, underpinning, facade, column and perimeter slab lowering, construction of a partial new basement along with drainage, and extensive temporary works which we'll go into. Key part of this project, as previously just mentioned, was Buckingham Palace was the neighbour opposite and the Queen, and extensive consultation was had with them and the local community of Belgravia, which is quite an affluent area of London. So some very interested neighbouring people, very wealthy area, and that meant that we had to employ a full-time community liaison officer to deal with any of their queries and concerns from the onset of the project. Also, a very interested party was Transport for London. They had a bus stop directly outside the project, which we required to relocate that bus stop, along with a number of lamp columns that were owned by Westminster City Council. So there was quite a long period of negotiations on those items prior to us commencing works on site, as we required also the bus lane for the erection of our facade retention. The works were also carried out under the Westminster City Council Code of Practice and under a Section 61 environmental order. A key part of the project that we highlighted during our tender submission was the need for all site vehicles to be inbound of the site boundary. It's quite a congested area. We couldn't have vehicles parked on the road, and key to this was us establishing a loading area within the site boundary, and this required extensive temporary works and backpropping to the lower ground floor slab, and the installation of a ramp from ground floor to that lower ground slab. And then the strict negotiation with Westminster City Council surrounding the number of lorry movements we could have on a daily basis. Another key item for us was the installation of a tower crane at a very early stage in the project. We required that tower crane to erect the facade retention to all 4 elevations. Key to this was the removal of 2 atrium glazing roof areas and the establishment of the tower crane base at basement level, and that base was a gravity base that was 8 metres square and 1.5 metres thick and heavily reinforced. Another item being a listed building within the centre of London. We had a number of heritage and salvage items. We had porticos entrances on Wilton Street, 100 square metres of stone on Chester Mews, 2 statues at roof level, and a number of windows that were listed, and these were all removed by a specialist subcontractor on our behalf and stored for later use in the rebuild project. Just hand over to Grant.
Thank you, Stu. So so as Stuart mentioned, 4 or 3.5 sides of the buildings had to be retained the facade. So our internal engineer, Swanton Consulting, designed a external facade retention system that consisted of towers linked with trusses, all out of steel. It was over 500 tonnes of steel in total that we pretty much planted on the pavement of Westminster. 2 of the side elevations of the building, we actually shut the pavement, but the main thoroughfare on Grosvenor Place we had to keep open. So there was a pedestrian tunnel circa 110 metres long, and we were erecting steel above it. Just to mention as well, the period of erection was about 20 weeks. At the time we were erecting this facade retention, we were internally soft stripping the building. We couldn't wait the full 20 weeks to start hard demolition, structural top-down demolition. So we kind of developed a scheme that would get the south end of the truss system up and the building facade clamped, which allowed us to demolish the southern end of the building while we're still erecting the facade at the northern end of the building. To give you a little cross-section through this is through the facade system on Grosvenor Place. The problem we had is the building facade was inset from the actual building retaining wall, the basement retaining wall, and the facade came down into the basement and it was carried on columns that sat on our basement slab. As part of our contract, we actually had to take that slab out and lower the basement in areas, which I'll come on to in a bit more detail. So you see the facade frame is denoted in orange. So the external leg sat on a designed concrete Kentledge pad. So that foundation was heavily reinforced. It acted as Kentledge weight, so the system didn't tip and move about. It also acted as a spreader platform to pass the weight through the pavement. I'll move through this very quickly. The green areas denote the concrete Kentledge blocks, which had to be carefully arranged and situated around live services, utilities covers, lamp columns, traffic lights, etc. To give you an idea of the concrete Kentledge, I mean, it was sort of 2.5 metres high, 1.5 metres wide, heavily reinforced, so it was a big job in itself just erecting that Kentledge. The actual internal leg of the facade came down into the basement and sat on a pile, so we had to do some very restrictive, low headroom piling in the basement to carry this column leg. So I think there was 36 in total temporary piles we had to sink. They were 750 diameter, they were about 12 metres deep. And once we'd sunk the pile, we then put a 5 metre plunge column into the pile, which then allowed us to connect the column leg to that pile. Before we could install the piles, we had to enable them. So the existing raft slab was about 1.5 metres thick. So we had to diamond stitch drill, as you can see, holes out, and literally pull the plug out. Headroom was restricted, so we had to use A-frame, portable A-frame lifting equipment. And there you can see the piling rig. I think we had about 3.3 metres travelling room through the basement to actually install these piles.
A key constraint that was put on us during the project was the installation of some 40 welfare cabins for the main works. This was not foreseen at tender stage, and we had to come up with a design where these cabins could be placed somewhere within the facade retention scheme. The requirement was that the main works that followed us had some 300 operatives to be on site, and they all needed to be housed. And there was nowhere off-site or any local area that we could place that amount of welfare. As you can see here, this is the start of the installation of the cabins within the facade retention on Grosvenor Place. It was installed by the tower crane. As part of the aesthetics of the local area as well, the client also instructed us to wrap the facade retention rather than encase it in monoflex. The issue with using traditional monoflex was we'd had to build a heavy scaffold frame within facade retention, and the way the wrap was constructed in large sections and printed with the outline of the building once it was completed actually made it look a lot aesthetically pleasing to the eye, and obviously to our neighbours as well. This was also one of the largest wraps, or if not the largest wrap, used in the UK at sort of 3,500 square metres and covered all 4 elevations of the structure. I'd just like to play now the video. This is the top-down time lapse for the project.
Yeah, so starting here, so obviously we've enabled the cranes, we've enabled the loading area at the northern end of the building. We've soft stripped the building at this stage fully. We're erecting the facade retention as we start this demolition. This is 6th level and plant level. This bit of the structure is not reliant on the facade retention system. It's above the retained elevation of facade. It's typical steel frame, concrete floor construction. and we're demolishing it top down. We're using 8 and 13 tonne demolition excavators fitted with either hydraulic munchers or hydraulic breakers, and we're using skid steer loaders to transfer the materials to a well hole. We're utilising an existing lift shaft to transfer the materials down to the lower ground floor slab at the northern end. As we come down floor by floor, we are boarding up the windows that we've removed, and we're erecting felt and batten to weatherproof the internal facade. It looks pretty easy what we're doing here, but believe me, it's not. We only had one way for materials to come into the building and materials to go out of the building. At the same time, we're doing heavy enabling in the basement, which I'll come on to in a bit more detail. So we also had materials coming up and out of the basement to the same area as materials that were being fed down and loading away. So logistically, it was quite a challenging job. But as you can see, we've demolished. We're down the basement now in the southern end of the building. We're still demolishing in staggered fashion at the northern end of the building. Very, very crudely, the area in blue, we had to lower the existing basement by 1.5 metres and construct a new permanent basement slab, including drainage. As I said earlier, the existing facade and the columns were actually situated on that existing basement slab. So we actually come up with a scheme to be able to take away the basement slab, take the weight of the column loading on the facade, and basically we erected these huge frames. So they were huge steel frames. There was 4 different scenarios of frames in total. I think the heaviest was about 54 tonnes, so massive frames. Again, very, very limited headroom in the basement, so lifting frames, block and tackles, etc. to get these things in place. So basically the sequence was erect the frame, clamp and load the existing column, cut the column, saw cut and break out a section of slab, excavate that area to formation level, install blinding, install drainage and a new 1.5 metre raft slab, extend and rejoin the column to take the facade load for us to then move the frame and move it on to its next location. If we can run that video, please. So something like this, one bay at a time. To give you an idea, each of these bays, the sequence of work took somewhere around 30 days just to create one bay and finish one bay before we could move that frame onto another location. At the same time, we're doing hard demolition upstairs and erecting facade retention. To give you an idea of how we sequence this work, obviously we couldn't open up too much areas at once because obviously we'd compromise the building. So it was kind of almost a sort of how you do an underpinning sequence, hit and miss fashion. We had 4 frames down in the basement that were working all at one time. Our plan was to get the southern end of the building completed earlier because we were going to hand over to an incoming building contractor, and that's how we worked around the basement. So this is one scenario frame. This is what we call a corner frame. This was literally used 4 times for the corners, each corner of the building. We had a single column frame. We also had a double column frame, so we could do a bay twice that size. And we had bay window frames, so we had 3 bay windows that we had to have a different, completely independent frame for. And we actually ended up putting in the permanent new steel that was in the follow-on builder's contract package. Can we run that video, please? Just to give you an idea of how restrictive this is. This is a time lapse of one bay being constructed. So frame goes up, column gets jacked and cut, excavate, slab and drainage, So yeah, new slab goes in, column gets extended. Frame comes down. And here's another scenario. It's the single column frame. So we had guys down there, I mean in total it was like 40 odd weeks down in this basement configuring this scheme. So we had guys that didn't see a lot of daylight, to be honest. So this really was the key challenge of the job. I kind of brushed over the top-down structural demolition, although it was a tremendous demolition, massive scale of building. I'd say the building was sort of 110 metres by nearly 50 metres wide. It was a huge footprint of a building. Once we'd constructed the new slab, we then installed a raking shore all around the perimeter of the basement, because part of our contract as well was to lower the middle of the site for a follow-on contractor to come in, link up with our new slab on the perimeter and form the rest of the raft slab. That's to give you an idea of the scale of the project. Obviously there's lots going on here. 2 tower cranes. We're still doing hard demolition, sort of central and northern end of the building, as well as doing what we've just showed you at the same time. So it took a lot of logistics planning. Obviously you had to keep people safe in the basement. You had to make sure none of the demolition debris made its way to the basement. A lot of crash deck, a lot of protection. Just to make the project a little bit more difficult, we were under pressure to hand over the southern end, or pretty much 2/3 of the site, to a follow-on build contractor, circa 12 weeks before we completed the project. So we're still demolishing the blue end and lowering the basement. At the same time, a follow-on contractor comes in and starts building the southern end.
The project successes for us were the recycling of some 1,400 tonnes of steel. Concrete and hardcore recycled was just under 37,500 tonnes. The project overall, we recycled over 98% of the material that came out of the site, and we achieved a BREEAM Excellence. Total man hours of work for just over 220,000 were incident and injury free, along with no environmental incidents. We was also awarded scores of 43 and 44 out of 50 by the Considerate Contractors scheme, and we completed the project on time and budget. And customers and third-party stakeholders were extremely satisfied, and at the end of the project we had a number of letters thanking us for the consideration that we'd taken in undertaking the works, and that we'd actually done what we said we was going to do at the very first tenant and neighbourhood liaison meetings. And if we're ready for questions.
Any questions?
There we go. Incredible presentation. I noticed minimal complaints was one of those complaints from Her Majesty.
No, we didn't have any.
That's great.
Actually,
Yeah,
no,
that's great.
I think she's in Balmoral for the duration.
Yeah.
So there've got to be some questions from our audience. So please, these gentlemen, you got a lot of. Yes, sir.
Was there any consideration given on the temporary work system for the external fabrication to, for instance, the proprietary system or R&D?
Yeah, R&D, but it would have been a lot more expensive. So that was the main consideration of using steel. It was built with the follow-on contractor in mind. That it was built in towers and bays pretty much, so it could be struck out section at a time, not a level at a time, if you like. So it was it was built in conjunction with the follow-on contractor.
And it also enabled us to, when we came to installing the welfare facility for the follow-on contractor, which was obviously a change in the contract works, we was able to facilitate the changes a lot easier than with the proprietary system. We'd have been stuck to modular changes.
Yeah, we had to beef our steel system up, certainly on Grosvenor Place where we had to fault the cabins. R&D would never have been man enough.
Did you rely to dismantle the facade?
No, so that's in the builder's package.
That's still up.
So,
Another question, Steve?
Yeah, how did you tie the external steel to the actual facade without damaging the facade?
it was clamped with a Dewey-Dag and timber clamp system. So it was heavy hardwood timber whalers clamped with traditional Dewey-Dag and wing nut.
There's a lot of negotiations on that with the Westminster Heritage Department to ensure that we didn't cause any damage to the listed structure as well.
Which was obviously photographed before we started and after.
Any other questions from the audience? One question, if I may, gentlemen. Obviously, the devil was in the details, and your videos articulated it and gave us a lot to think about. But what was the maximum movement tolerance allowed for the facade retention in the design, and how was that monitored?
Good question, Jim. We actually had two different tolerances. So we had a horizontal tolerance of 15 millimeters, and we had a tilt leveling system. So we had tilt. They were actually wireless tilt meters fitted on the external facade. They gave us a real-time reading. If we did have a breach, they would give us an instant alert. On the vertical movement, obviously we're taking away column loads or transferring column loads. It was a tight tolerance of 10 mil. That was a slightly different. That was hydrostatic leveling cells that were fitted horizontally around the floors of the building, and they monitored that vertical movement.
That's great. Well, there's no question why you can see this was the 2018 World Demolition Award winner for urban demolition, greater than $10 million in value. So, gentlemen, thank you very much for your presentation. Congratulations.
Thank you.